Question 7. While Question 7. While conducting the Young's double slit experiment, a student replaced the two slits with a large opaque plate in the xy plane containing two small holes that act as two coherent point sources S1 and S2 emitting light of wavelength 600 nanometer. The student mistakenly placed the screen parallel to the xy plane for which z is greater than 0 at a distance d is equal to 3 meter from the midpoint of S1 and S2 as shown symmetrically in the figure. The distance between the sources d is equal to 0.603 millimeter and the origin O is at the intersection of the screen and the line joining S1 and S2. So we have to choose the correct option in which the intensity pattern can be seen. First option is given hyperbolic bright and dark band with foci symmetrically placed on O in the x direction. Option B, semicircular bright and dark band centered at point O. Third, the right very close to point O will be dark, and the fourth, straight bright and dark band parallel to the x-axis. So we would like to know that separation is given between S1 and S2 is small d and they are placed at a distance between slit and the screen is capital D. Wavelength is also given and this is a coherent system. So we would like to calculate fringe pattern. So we would like to calculate fringe pattern for this. So we know that d by d lambda. So that's equal to d by lambda. So because from this part 0.6003 into 10 to the power minus 3 upon 6 because it is given and lambda is given how much, that is 600 nanometer, 600 to 10 to the power minus 9. So finally from this part we got that is equal to 6003 divided by 6. Solving this we got that is equal to 100.5. So from this part we got there would be d by d lambda that is equal to 1.000 point from this part. Now we are going to calculate that d because 2n plus 1 lambda by d. So from this part because we got the ratio n lambda is equal to 2d sin theta. So from this part we will calculate d is equal to 1000 plus 1 by 2 into lambda. Solving this we will get, so we are going to calculate the fringe pattern we obtain. So from this data we calculated here in the solution we got there would be semicircular bright and dark fringes centered at point O because we are getting dark and bright fringes. So we calculated for bright fringe as well as for dark fringe. So we got these are regions very close to the point O will be dark. So means the regions over here will be equal is a dark and they will form, they will be like circular fringes formed. If this is a screen, so there would be circular fringes formed. So we can say dark, bright, dark, bright, dark, bright. So we will calculate the part difference for bright as well as for dark fringes for which the value is small d and capital D. So in this question what we have to observe? We know that as we are given the separation between the slit and the screen and the separation between two slits on the basis of these two quantities and wavelength is also given. So what we will calculate the fringe pattern for the central maxima n should be equal to 1, though that should be equal to my wavelength value. It is approximately 1000 times. So we got option semicircular bright and dark bands will appear which are centered at point O, and second region we're very close to point O will be dark. Hence two options are correct and these are option B and option C. These are the two correct choices in this question. Now we will go for question 8. Question 8. In an experiment to determine the acceleration due to gravity g, the formula used for the time period of a periodic motion is t equal to 2 pi under root of 7 capital R minus small r upon 5z. The values of r and r are measured to be 60 plus minus 1 millimeter and 10 plus minus 1 millimeter respectively. In 5 successive measurements, the time period is found to be 0.52 seconds, 0.567, 0.57, 0.54 and 0.59 second. The least count of the watch used for the measurement of time period is 0.01 second. We have to find out the correct statement. So it is more than one correct. This question is more than one correct. So we know that measured value of r. Okay, so measured, we will first from the first option we are given the error in the measurement of small r. So we are going measured value of r, that should be equal to 10 plus minus 1 millimeter. So we can the relative error that should be equal to delta r upon r, and it should be equal to 1 upon 10. So we can say this is approximately equal to 10%. Hence option A is the correct choice. Now we are going to calculate the errors in the measurement of time t. So this can be calculated from the relation t is equal to 2 pi under root of 7 capital R minus r upon 5 into g. So from this part we will calculate the capital T from this part. So we will calculate here, that is it is given as 60 plus 1 value of capital R, and this is 61 and this is 10 plus minus 1. So for this relationship we will calculate T average value. So we will find the average of all the datas TIs divided by number of experiment done to perform this. So 0.52 plus 0.56 plus 0.57 plus 0.54 plus 0.59 divided by 5. Solving these values we got that it is sum, and calculating their average that is approximately equal to 0.556 second, and it is approximately equal to 0.56 second. Hence we can say as it is equal to 0.5 second. So we are going to calculate time period or time error in this part. So that should be equal to 0.01 divided by 0.56. Solving this we got it is around 1.97%. So that is not the correct option. Now we are going to calculate the error in the measurement of t is approximately equal to 2%. So this is also incorrect option. Now error in the measurement of g. So in this part we will use the basic method. Now we know that reported value for r, reported value of r minus r is equal to 50 plus minus 2 millimeter. Similarly relative error in capital R minus small should be equal to 2 by 50, and it would be equal to 1 upon 4, that is taken to be as 4% from this relation. Now this is also incorrect one. Now option D we will check relative error in the gravity. So we know that relative error in the gravity as T equal to 2 pi under root of 7 r minus r upon 5 into z. So calculating relative change in error gravity, that is equal to, or from this relation we can calculate, that is delta t by t is equal to delta r minus r divided by r minus r plus delta g by g. Okay, so from this relation we will get our answer as time period, because we will square both the terms. When we will square we will do 2 times. So it is equal to 2 delta t by t plus delta r minus r upon r minus r should be equal to delta g by g. Placing the values of delta t by t and these two values, so we got it is around 7.5%. That is equal to delta g by g. Hence we need to check it is also absolutely wrong. So we got the error in the measurement of small r is option A is correct. Small measurement in the value of small r is correct, that is 10%. Measurement in the value of capital T, that is incorrect. Measurement in the value of G, that is given as 11%, but we calculate 7.5%, which is also wrong. Hence option A is the correct choice. Question 9. A rigid wire loop of a square shape having side of length L, resistance R is moving along the x-axis with the constant velocity v0 in the plane of the paper. At t equal to 0, the rigid right edge of the loop enters a region of length 3L where there is a uniform magnetic field B0 into the plane of the paper as shown in the figure. For sufficiently large Vn, the loop eventually crosses the region. Let x be the location of the right edge of the loop, and let Vx, Ix and Fx represent the velocity of the loop, current in the loop and force of the loop respectively as a function of x. Counterclockwise current is taken as positive, so we have to find out which of the following schematic plot is correct when we ignore the gravity. So we are given the graph here, and there is a magnetic field into the plane of paper, and there are different parameters 0 to L to 2L to 3L to 4L, but the range of the magnetic field is there from 0 to 3L. Now the loop 1 is about to enter into the magnetic field, so we have to calculate the expression for force, current and velocity as a function of x. Which one is correct over here? So according to according to the concept of motional EMF, the force experienced by a current carrying coil of length L is taken as B into I into L, but here current is a function of x because a loop is entering, so we will write here BIL sin theta. So sin theta is taken as 135 because angle between current and that is 135, so we can say that is Ix into L into B sin 135, so that is taken to be as minus of I as a function of x into L into B. So this is what a force, and it should be equal to ma, mass into acceleration. So we got A is V into dV by dx. So we can say now we are going to calculate the EMF. EMF is equal to VLV. So we know that EMF is also a function VL, velocity as a function of x. And now already we are given the value of x from the above part. So we got Ix is equal to Vx divided by resistance R of the circuit. So we consider this as equation number 1. From the force equation we got m into V into dV by dx should be equal to negative of V square L square upon R into velocity, and differentiating we got the value of dV by dx, that is equal to minus of V square L square upon m into R. Since it is given the current I is anti-clockwise or counterclockwise, anti-clockwise, we assume this is equation number 2, and the current is anti-clockwise. Now we can say that in the second option, in the first part we got that dV by dx is equal to V square L square upon m into R, and now Ix is equal to 0 when Fx is equal to 0, because we know that when velocity is equal to constant, acceleration need to 0. For this, current entering Ix will be equal to 0, and then force experienced by that current carrying coil will also be 0. If we consider current is clockwise, because what we need to consider in this question, I need to consider current is clockwise, anti-clockwise for two different loops, as I need to draw it like this. Means as this is two sections are there, and now this is the variation of length x from this part, This is the resistance R. Magnetic field is into the plane of paper, and the force experienced by this current carrying, as current is going upward as a function of x, and we can consider it is constant. That's why it is 0 when the velocity is constant, because there is not any movement, so no motional EMF, so no current, and no force experienced by this. And now there is a force Fx. Also their x is varying from 0 to this position. Now when it entered into the magnetic field, means we can say no current is there, but when it is about to out, so we can say this is the value of my current Ix, and the force experience would be in this direction. So we know that when the current is clockwise, like this in third case, when current is clockwise, speed decreases linearly in accordance with the equation 2 we calculated, that is dv by dx is equal to minus of v square L square upon m into r. So when the current is considered to be clockwise, speed decreases as a function of x, thus current magnitude decreases linearly. So we can say F is always in negative x direction from this part. So from this relationship we got that option option D for velocity as a function of x, and as well as the function for current option C, because this is given for your clockwise, this is given for your anti-clockwise, and we will consider, and there is not any current in between when the loop was there in the magnetic field. Similarly velocity was constant into that. So this is for mid section. So we can say option C and option D are the correct graphs for current and velocity as a function of x. Question 10. Question 10. Light of wavelength lambda ph falls on a cathode plates inside a vacuum tube as shown in the figure. The work function of the cathode surface is phi, and the anode is a wire mass of conducting material capped at a distance d from the cathode. A potential difference V is maintained between the electrodes if the minimum de Broglie wavelength of the electron passing through the anode is lambda e. We have to choose the correct option among the given options. Now we are given a graph over here, so we can say light falls on this with a particular intensity Hc upon lambda ph. There is a work function of this, that is phi. Also this will move with certain kinetic energy, but there is a stopping potential from this side. Also there is neutron side in this question, that is anode. Okay, so anode wavelength is there. Now we need to we will check the options. For a large potential difference, V is greater than phi upon E. Lambda E is approximately half if V is made 4 times. We will check it from the photoelectric effect equation. Second, if wavelength of electron increases at the anode side at the same rate as wavelength for photons, because Hc by phi is greater than wavelength, lambda is approximately half if D is doubled, and lambda decreases with the increase in 0 and lambda ph. So from the photoelectric effect equations we know that kinetic energy of the movement K max is equal to Hc by lambda, this is the energy of the incident photon, minus work function plus stopping potential. So we know that K max is what? K max is equal to maximum energy of electron reaching at anode. So we got this. We know that we know that there is a relationship between momentum and kinetic energy. So we know that K is equal to P square by twice of m, and from the de Broglie relation lambda is equal to h upon P. So we can say P is equal to h upon lambda. From these two relations we got a new relation, that is equal to h square upon twice of m into lambda of anode, because these emitted electron from cathode are about to reach anode part, so they would have their kinetic energy. So we would like to represent them in terms of momentum. So that should be equal to Hc by lambda ph plus minus, it would be minus work function negative, plus E into V. So from these from this first equation we know that if work function increases and lambda p decreases, it also increases, then the value of hc by lambda ph minus phi decreases. Because if phi is increases and lambda ph also increases, the value of hc by lambda minus phi will decrease. As a result, lambda of electron, as a result from this part, as a result, wavelength of electron increases, lambda e is independent of d, and clearly lambda e and lambda ph do not increase at the same rate. So although we can differentiate it with respect to lambda also, we can get the same relation. So from this part we got only when from this relation we know that from this, for the large potential difference V is greater than phi upon E, means work function or value of the stopping potential is greater than the work function. So what will happen? The wavelength of the electron is approximately half of the potential is made 4 times. So we got this relation. Only option A is the correct choice over here. Question 10. Two thin circular discs of mass m and 4m having radii of a and 2a respectively are rigidly fixed by a massless right rod of length L equal to 24a. So the separation is given 24a whole under root through their centers. The assembly is laid on a firm and flat surface and set rolling. This is a keyword in the question. Set rolling without slipping on a surface so that the angular speed about the axis of the rod is omega. It is given. Angular momentum of the entire assembly about the point O is L. We can see this in the figure also. So which of the following statement is correct? So we need to choose the correct statement. Now we will check. The magnitude of angular momentum of the assembly about its center of mass is 7 ma square into omega by 2. Let's check. We know that here tan, if it makes theta over here like this, so this will make a right angle. So easily we can say tan theta is equal to a by L, that is equal to 1 upon under root of 24 a upon that is a also. So we got from this relation that sin theta is equal to 1 by 5. Now as sin theta is equal to 1 by 5 from this part. Now we are, because we need to calculate the value of theta, whether this is small or large. Now angular momentum about the axis of rotation. So we know that this is in pure rolling and we wanted to calculate angular momentum about the axis of center of mass. That should be equal to moment of inertia of the system and its common angular velocity. That should be equal to m into a square by 2 plus mass of another disk into its radius by 2 into omega common. So we got from solving this part, we got that is 4 into 4 16 plus 1, that is 17. So 17 into m into a square by 2 into omega, hence option A is the correct choice. Now we are going to calculate the magnitude of the z components. Magnitude of the z components of angular momentum is 55 ma square. So we are going to calculate angular momentum about this point. For this we need to calculate what is the separation of this distance. Let it is equal to x. So this would be a triangle like this. This is given a, it is given as 24a under root. This is a right angle triangle. So using Pythagoras theorem, this would be equal to under root of 25 into a square. So should be equal to 5 into a. Now because we are going to calculate its angular momentum about the point z, so that should be equal to here, that as we got this separation x is equal to how much, that is equal to 5 into a. Now we are going to take velocity of disk A. velocity of disk A, that should be equal to VA equal to omega z into x, because if there is a rod like this and it is about to rotate, so there is a point P over here, it is at a distance x and it's a tangential velocity Vt, so we can say velocity of Vt is equal to x into omega z. But there is a rolling also, so what, when there is a rolling, so we can say the velocity of the point of contact is 0 with respect to ground. So we are going to calculate that value. Disk performs pure rolling. Disk performs pure rolling. So in case of pure rolling, the velocity of point with respect to ground is equal to or considered to be 0, and that is equal to velocity of A minus its velocity of center of mass. So that should be equal to how much? Omega into z into x. That should be equal to the length, that is A into omega. Okay, so from this part, x is given as 5 into A, that is A omega. A would be cancelled out, so we got omega z is equal to omega by 5. So we got the velocity will be equal to omega by 5. So option D is correct. Option C is the wrong choice. Option B is again the wrong choice, but option A is the correct choice. So magnitude of angular momentum of the z axis, so we can easily calculate it. Okay, so for this part we will collect L is equal to mx into its Vt, or we can say I into omega and I into omega for this part. So we will get the moment angular momentum of the system.